For the AI models of Bytee, first of all, we have prepared a skill matching and recommendation system. So whenever the learners will have the requirement to search a skill, then various teachers or senior students who have posted which skills they can teach, so there should be a compatibility match or a similarity match, and based on that there should be a sequence of skills should be shown. So we have made a recommendation model for that. So for this recommendation model, I have used BERT to generate the embeddings or text embeddings, and I have stored those text embeddings in a vector database called FIAS. And after that, I have done cosine similarity and for the contextual matching and ranking of this. After I have also extracted various features from those text so that I can explicitly engineer and give a good ranking or scoring. Now I am just going to show you how it works. This is the code. First, we have pre-processed the data. We have pre-processed the data using NLTK corpus. After the data is being pre-processed, as you can see, we have loaded the different clients and their specific what are the skills required. If he is a freelancer, what are the skills he can teach or what he will be providing. After that, we have generated text embedding. Here I have used TF-IDF vectorizer to generate the text embeddings, and once the text embeddings are generated, then we can see our initial similarity scores are calculated for the between the freelancers and their respective tasks. After that, we have used BART, another encoding method in place of TF-IDF for BART encoding, to compare that whether BART is better, working better, or the TF-IDF vectorizer is working better. Then we have generated its freelancing the similarity scores. I have also tried a separate thing like tone analysis, uh, like how what according to the reviews the particular freelancer has got. So how much good or how much apt he is in his particular skills that he is providing. So based on that also ranking has been done. So currently I have commented out, then I have calculated the skills similarity. And for each client, suppose we have 10 freelancers and 5 clients, then for each client we have a similarity score of each freelancer, and based on that we will give a sequence of skills that will be given for each client. So finally, as you can see, for example, a client A, he searches for a particular skill, then based on this the different choices will be shown, like freelancer 2 has the highest similarity, so it will be at the top, then freelancer 7, then freelancer 1, and so on. Moving to the next AI model. Okay, so the next AI models is exchange value predictor or T coffee credits. Now we have a system that in exchange of a skill that you want to learn, you can give him some credits. So the credits can be in our current implementation in the website that is present. The user chooses a number of credits, but the user may choose very low credits, or the seeker or who is giving the skill may demand very high credits. To make a trade-off, we have made a small machine learning model using XGBoost, and obviously to pre-process the text data we have used NLTK library. I have lemmatized it using wordlet lemmatizer, and I have used random forest and XGBoost and then compared their scores to get so I have got better results in XGBoost, and like I have got an RMSE of 0.023 and MSE of 0.003 for XGBoost. Yes, XGBoost. So we will be choosing that model to generate the say suppose T credits, how much credits should be exchanged for a particular skill if you want to learn from a particular uh, author or from a particular freelancer. Now moving towards our next AI model, which is the trust scoring model. Like based on the reviews that a particular freelancer or a teacher or someone, a senior student who is teaching the skill gets, we generate a trust score or rating of that particular member. Uh, Here for this we again use the BERT or distill BERT, TF-IDF, different embeddings, embedding generator, better to say, different vectorized embedding generator to generate the embeddings from the reviews, which is a text. Then after that I again use light gbm, XGBoost, random forest models to uh, predict which of these model is performing the best for this particular generating a trust score. And after that we evaluate. Now for this generating this trust score, we have two methods we have presented. First one is NLP based approach. First I will show the code and results of that initially. Yeah, so this is the code. So this is the parts of the dataset I have taken from Kaggle. It is a sentiment analysis reviews dataset. So I have loaded the files and all. After that, to view the data, whether there is some imbalance in the data, etc. Then we have plotted something. How is the distribution of the data? A bit of feature engineering for the tokens, length of the tokens, and so on. How many review lengths? What is the length of each review? So I have plotted few graphs which we can also find in our presentation PPT slides. After that I have trained the model. So after balancing the dataset how the distribution looks, then we are defining the preprocessor for the text. When the text is pre-processed, like the emojis are removed, then we can the stop words are removed. We have done this type of text pre-processing. Once the text is pre-processed, we have encoded the levels and created a pipeline. After that, so you have used the sentence encoder. Here we have used the sentence encoder variation, which is obviously universal sentence encoder. We can use BERT, we can use TF-IDF, anything. Then after that we have built the model, and once this is basically our model, after that I have trained the model for few epochs, specifically 10 epochs we have trained the model. And once the model is trained, we have plotted the curves. How does this look? So this model can generate good results. Whenever a few reviews are given, say suppose 2 or 3 reviews are given, it can generate a trust score. But the point is that these NLP models are sometimes difficult to deploy on the system, on the website, as we are using free deployment services like Vercel and Render. So I have made another version of generating a trust score using pre-trained LLM like Gemini. So using that LLM Gemini also we can generate the trust code. This was bit easy, like we can just use the Gemini API key and we can call it. Let me also show that code. So that the code is present here. So using I have called Gemini 2.0 flash model, and using that I can give the reviews and generate the trust score. Now moving on to our next AI model, which is complaint classification and routing model. Okay, so this model is made like when the users give different reviews or they face certain problems or complaints, or in general in our college also, if the student face a particular problem, then he should be directed to a particular place. So here also we are processing the text using BERT, and we are training the model. The specifications of learning rate, etc., are specified here, and after that we are evaluating the model. A very similar type of model like the previous. Next one is a sentiment analysis and distress detection model. Again, from the reviews that the students are posting or the posts that they are talking in the community, we can generate a score, or we can generate an analysis of about the emotional situation or the stress, how much stressed a student is. So basically it will be very similar to our trust score generation model, so I have not made a separate model for that. Moving to the next and a very important model, that is the spam reviews model. Like whenever people are commenting or posting something on the community, there is a high chance that those are spam, like they are useless kind of messages. So we have a machine learning model to detect that. So here also first we do a basic EDA of the texts that are I have taken a dataset from the Kaggle containing a spam and ham, and I have used analytical library to that. Let's move on to the code to give a brief idea of the same. So you will get the code here in Q&A. So this is the code. So first we have taken the message, we have done a bit of pre-processing on the code. When the pre-processing is done, then we have plotted the code to see how much percent of ham and spam is there. As this dataset is imbalanced, so we have done a bit of balancing of the dataset. We have done a processing of the dataset using analytical library. We have removed the stop words and all. After that, once the data set is kind of balanced, we have plotted to see what is the parameter number of characters in each line with respect to the spam messages and the ham messages are the original messages that are present. And we have done this is the plot between the number of characters of spam and ham sentences to give us to give the model a context how to predict. Okay. Next we have done a few more processings. Let me show you the word clouds. So this is the word cloud that is present for the spam messages, and a similar word cloud for the ham messages we can get. And based on this I have made a predictor. Now for this I have used various types of models to compare and get a good model. Like first, initially to encode the text I have used TF-IDF vectorizer. Now I have imported the classification matrix. Now to fit I have used multinomial, Bernoulli, Gaussian. I have also used random forest, the standards like random forest and all that is present in like here we can see I have used disease-centric classifier, k-nearest neighbors, random forest, XGBoost, bagging, okay, gradient boosting classifier. And after that I have made all those. And like we do for a normal hyperparameter fine tuning or any kind that type of setup, I have created a certain setup and then I have trained this classifier. I have got accuracy as shown here. So after that I have seen for each classification model what is the test accuracy and precision, and based on that I have chosen the best model. And then I have downloaded the best model in a pickle format. This is the final model. I have installed the model in a pickle format, which is saved here, model.pickle. And then I have made a spam classifier app.py where I have loaded this model.pickle, and we can upload this in our website. Our next model is a topic modeling. Like whenever a user posts something, then which topic it belongs to classify it automatically, I have made a LDA kind of model. This is also very similar. We have used BERT for embedding, and then we have used a classical LDA model to group it into particular things. As moving on, next coming to one of the important features, which is a YouTube video explainer. Now many a times the student faces difficulties while watching a YouTube video or any lecture from the online. So if the transcript is available of that particular video, transcript means a written text, then I have made a RAG. So what way am I doing that? Whenever you give the link of a particular YouTube video, then it extracts the transcripts from that video and then it passes to an embedding model, and it stores the embedding in a vector database as shown in this diagram. It stores the model in a vector database. Now this is stored in the vector database to derive a context. So without context, any kind of pre-trained models like LLMs, they hallucinate. So this context will help the model not to hallucinate. Now whenever we are asking a question, that question is again encoded using the same embedding model. Then we perform a similarity search between the query and this vector database and the LLM. Based on this combined similarity search result and the query, the LLM gives out a result which is stored. So this is our YouTube video summarizer. So two things we have shown. One is YouTube video summarizer and question answering system, so which you can find in the RAG. There are a few Bytee RAG. This file, it develops the RAG. Like first of all we are finding the URL. From the URL we are extracting the ID, then from the ID we are getting the transcript from that particular video. After that we are summarizing it. This is a Streamlit app I have made, based on which we are summarizing the video, and based on this the transcript is stored in the vector database, and after that we can question answer. So multiple questions can be asked. So this is our next ML model, is a feedback summarizer and soft skill learner. So for this I have not done much. I have just used a pre-trained LLM like a Gemini model, and you can ask any question to that Gemini model. I have given a proper prompt in the backend that will to make it hallucinate less, and it will give you ideas about the soft skills which you will get in the soft skill folder. So this is all about the ML models I made for Bytee. Thank you.